Hello and welcome to another video. In this video we're going to be working on maximum sum of distinct subarrays with length k, and going to be doing this live as the previous few videos. So in this one you're given an integer array nums and an integer k, and you want to find the maximum subarray, sum of all subarrays that meet the following conditions, the length is k, and all elements that are distinct. Return the maximum subarray sum of all the subarrays that meet the conditions. If it doesn't meet 0, subarray is a continuous non-empty sequence. Okay. So here, basically they're saying k is 3, so it'd be like this, or so on. And you have to get a sequence that is doesn't have any duplicates, so probably going to be this one here, which is 15. You can't use something like this. Here there's nothing. Okay. So I think this one's relatively straightforward. Constraints looking like we want to use linear or n log n. But basically the idea is we can just have a window of, like, this is basically the same as the problem that's like a subarray with like no duplicate elements or something. And essentially what we can do here is we can just maintain a window of elements, and we can shrink it under two conditions, and the conditions will be length greater than k or duplicate. So length greater than k is pretty easy, like we're just going to be 1 greater, so we'll just shrink it by 1 here. And duplicate, we can just shrink until we get rid of duplicate. And then once we do these two conditions, we can just check, is length k? If it is, get result. So it should be pretty simple, I think, here. Like, it's basically just, yeah, like a standard sliding window. So let's just allocate space for some stuff. So we'll say a result, we'll make it 0. We'll have a left pointer, 0. So we need a hash map to find duplicates or a set. Either one's fine. Guess let's use a set. Okay. Yeah, I think that's it. Now we just go through our numbers and do our stuff. So the right pointer will start at 0. And then all we got to do here is check, do we already have this number in our set? If we do, keep shrinking. So while uniques contains, keep shrinking. So we're going to remove the left element and keep shrinking the window. So yeah. All right, now we're going to add this element back in. Okay, and we also have to make sure that our window is not too big. So if it's greater than k, we're going to get rid of the leftmost element as well. Okay. Now we should have a valid window, and then we just basically, oh, we need to do, I forgot one more thing. We need to actually store the sum as we go. Yeah, so we can do that as well. So, yeah. So we're getting rid of this, and same here. Okay. And then we need to add the right total. We can do that here. Okay, so now we should have a valid window, but it might be too short, so we're going to check for that. So if it's k, then we get the result. So all right, And then we just return the result, and if we never found anything, we should just have 0. Let's see what we get. Oh. Ooh. Oh, so it's a long, so we need a long. Alright. Okay, so pretty straightforward one, just basically using the trick, or not really a trick, but it's essentially when we hit an element that we've seen before, just keep removing until we remove that element. And then also, if we're longer than k, which we can be by 1, then we just shrink it as well. You can combine these two if you want, or these two if you want, but it doesn't really make a difference. Okay. So, yeah. So pretty straightforward one. Linear time O of n space here because of the numbers. And yeah, that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.